Okay, I'm going to go with recording it, and I'll upload it after,
Sure.
just so you're not waiting anymore. Okay, so we've basically got Manny today giving us a talk on Python multi-threading and GIL, so I'm going to hand over to her now.
Hello, everyone. This is a short presentation on my Python multi-threading and GIL. First of all, you might all know better than me in this topic, but how I found out about the Python multi-threading and the GIL problems is like we're a small team working on some testing applications for middleware, and we had to have a set of boxes which is running on the racks, and then we sometimes the boxes get the live feed from the satellite, and then we test on this live feeds. Sometimes we will test with the streams, so we'll have a stream player set up somewhere which will play out the streams into these boxes, and we have to do the tests on top of it. So how I got into the problem is initially I thought, okay, it's better like we make one thread to start the stream and the other test to run the test. So once the test finishes, then we'll stop that particular stream and start another stream and things like that. So just started writing threads, and after some time I realized, a couple of tries, and then realized that the thread which I have spawned for starting the stream was never starting the stream, and when I join, it'll always stop the stream and come back. So that's when I realized, so what's the problem going on here? So there should be something else, because it's a normal thread which in C scenarios it you just start the stream and play out on the background, and then I can go ahead and do my testing on the main thread. But this was not happening. That's when I found out about this GIL. So feel free to give your inputs or questions. And then, so the topics I'm covering today is what's multi-threading and problems with multi-threading in Python, and what is global interpreter log, and advantages, disadvantages of GIL, and what are the alternatives to multi-threading. So we all know that the threads are the light-rate processes, mainly which uses this in a particular process we can have many number of threads, and which uses the common shared memory, and the control can be passed to the parent, and from the main thread to the parent, and thread child to the parent. So this so we can also see that there is not much of a memory overhead, but which is, in case of processes, we should be taking care of that. And they are cheaper than the process, and threads are mainly used for concurrency and parallelism. And they, in a single process, it shares the code, files, and data, but each thread has its own stacks and registers. So this is in general about threads. And how do we create threads in Python is we import a module called import threading, and then define a function, and on the threading we init the thread with the function name, and we do the whatever the thread needs to do. We use the thread.start and join when we are finished with a particular thread. So that's how we do it in Python. So we can see the notes. Yeah. And then what are the limitations in Python multi-threading? So basically we use the CPython interpreters in Python, mostly PyPy or any interpreters which comes for the Python. So here we can, over the period of time we'll find out there is only one thread running at any point of time. So we are not improving any performance. Some experiments have shown that in fact the single-threaded programs are much faster than the multi-threaded programs in Python. And then sometimes it's really hard to understand the multi-threaded code in terms of Python. And there is also, we have to do the synchronization of the threads on our own, so by means of lock and releasing the lock and things like that, so which is causing the potential race conditions. And at any point of time there is only one thread which will be running, so which is nothing but the global interpreter log. What is it's So GIL is a mechanism where the interpreters synchronize the execution of thread for ourselves. So we don't, even though we have multiple threads in our, from the programmer's perspective, we look like we are doing a multi-threading. But internally, the GIL will be like it's a mutex which controls, okay, I'm going to run this particular thread at this point of time. And then, okay, now I stop that, and then when give the control to the mutex gives the controls, releases the control to the next thread, and then the GIL takes care of it. So at any point of time, only one native thread will be run. Even though we have multi-core processors, there will be only one processor which will be used at any point of time. So, I mean, this which is not a very effective thing if we see in a practical point of view. And there are some popular interpreters that have a GIL or in for C, Python, and Ruby MRI, which some interpreters doesn't have. Some things like Java, Python, and other interpreters doesn't have the GIL problem. And why the Python is written with GIL is because C Python's memory management is basically not thread safe, and the running thread, which is, well, it's the normal process where the running thread will hold the GIL and it will be released on I/O and sometimes on ticks. So we have a counter in terms of tick, which based on the configuration on the interpreter. So if it is 100 ticks, then it will release from one thread to the another thread, and so on. So this is the main part of GIL, and there are also some very intrinsic operations in terms of numpy and things like that, which doesn't have GIL. So it is internally taken care by the libraries as it is. Even though we see this as a limitation, there are some advantages of GIL. So this is for mainly easy integration of C libraries. Mostly they are not thread safe, and which is much faster in single-threaded case. And if there is an I/O bound programs, then it is faster in multi-threaded case as well. But if it is CPU bound, then it is not. Which even if it will be faster in CPU bound programs, but in terms of like if we don't do intensive work in C libraries. The limitations of GIL, we have seen that there is only it allows only one thread. It controls the switches between the threads. It prevents the multi-threaded C Python programs from taking full advantage of the multiprocessor systems because it allows only use only one processor and one thread any time. And long-running operations like image processing and numpy and number crunching happen outside of GIL, so GIL doesn't limit that. And so it's only in multi-threaded programs this GIL is a limitation. The single-threaded programs will run straightforward. And there are some patches which is done by some Python communities and some developers which were submitted but were rejected because they were slowing down the single-threaded programs. So it was a bit faster for multi-thread, but it was completely slowing down the single-threaded programs, so they were not accepted. So still in Python 3 as well, we have GIL as it is. So how we solve the problem in terms of multi-threading is we use multiprocessing module instead of multi-threading, and we could get our problem sorted out. And there are more information on Stack Exchange questions and Stack Overflow, and David Beasley is the one who has done lots of research on the GIL, and he has given lots of information on like research and information on how each Python version behaves in terms of GIL. So more on that. Thank you. It's a short presentation.
Cool. Thanks for that. Do you want to tell us a bit more about the multiprocessing stuff you did? So what change did that involve?
The multiprocessing stuff we have, we have imported multiprocessing modules, and then we had a stream player module which was running. I mean, we've invoked the stream player. We didn't have anything shared between the main process and the multiprocess. So it's just stopping. We started the stream player using the process 1 started the stream player in the process 2, and then once the stream player is started, we pass the message to the main process saying that the stream has started. So we also have something. I mean, the stream player is in a completely different machine or a Linux box. So we had a bit of a network host socket communication as well, which starts on the network protocol. And then once it's started, then we'll just give the control back to the main thread that the stream has started, and we didn't have to synchronize anything with the stream player once it started. It was like a background process which is running all the time. So that's it. Any questions?
Okay, then that's it. Brilliant. Thank you very much.
Thank you.